OK，好，那我们来开始今天的 lecture，OK？那一样，今天大家可以看到吗？大家看得到吗？
好像看不到
哎，好像看不到，对不对？
好像没有画。
再来一次。OK，这样 OK 吗？有了吗
OK，
？OK，好，谢谢。好，来，那我们 let's start today's lecture. Today's lecture 12. OK. Also before we begin, 我们学校好像现在规定就是我们应该是会线上授课到学期末了。那这就表示我们期末考应该会是以线上考试的方式。那所以就像我刚刚一开始讲的一样，那个我会再给一个试着线上模拟考，让大家熟悉一下线上考试的环境。如果大家还没有考过线上考试的话，那这个考试主要会是在 Moodle 上面执行。那所以我可能会让你们大家稍微熟悉一下 Moodle 的操作，线上考试操作的方式。所以我会给一个比较简单一个线上模拟考试的这个形式，让大家去熟悉一下。OK。那我会在下个礼拜上课前给这个模拟考试，所以要是有问题的，可以在下个礼拜的课堂上提出疑问来，好不好 ？All right. Okay. So let's start today's lecture. Today's lecture again, we're gonna do a quick review on last week's lecture. Now, last week we talked about mostly AMPS operation. You have a subscriber who's initializing the call, MTSO verify and authorize the number. MTSO issue a user's phone number indicating send and receive traffic. MTSO sends a ringing tone to the party by paging. Now, if the destination or the party answer, the MTSO establish that circuit's connection for billing. Now, whenever neither one of those hang up, they will release the circuits free to channel complete the building. So you should know about the entire operation, right? Of how do you making a phone call from the beginning, dial the number, establish until you hang up the phone. Okay. Now, last week we also talk about first generation of analog, first generation of cell phone, which is analog, which you have two channel, okay, one for a two set of channel, base station to mobile device to base station. Those two set of channel will break down to two separate set. So you have two forwarding, two reversing, okay, to break down for two operator, two telephone company, okay. Then the total channel are listed 416 channels. Okay, 21 channel for control, 395 for conversation channel. From the first generation move down to second generation is changing from analog communication to a digital communication. Now, sorry. So for the first generation is pure analog. The second generation is digital. Now, once you have a digitize those channel, you can have encryption on the second generation, okay, which prevent any type of eardropping or provide what we call the security. Because it's digitized, now everything changes to 0 and 1 bits. It's possible for error detection and error correction on the second generation traffic. And also the channel access on second generation allow the channel to be dynamically shared by a number of users using time division, okay? So the first generation is analog. So using frequency division multiple access, you will have a 2M channel. 1M channel is for reversing, 1M channel is for forwarding. Now for each duplex connection, for each user's connection, you need to assign two channel, one forward and one reverse. Now in this approach, the disadvantage on this is you can have only at most one channel or both channel actually idle. you will not speak and listening at the same time. So it means that neither forwarding or reverse channel are idle at most of the time. So that's a disadvantage. However, you need to assign 2 channels for each users. Now for the second generation, the number of channels now for each cell also break down to half reverse, half forwarding. Still a duplex communication assigned to each users. Now, let's set that of each physical channel, each frequency of physical channel now is divided into a set of logical channel. Okay, now logical channel can divide it by time. Okay, so kind of like a time division multiplier access concept. Okay. Now for the second generation or third generation, they build over on top of the general structure of a GSM structure. So on GSM structure, on the left side, you will have a mobile station. In the middle, you will have a base station subsystem. And from the right side, at the right side, you will have a network subsystem, which allow you to connect to a public telephone switching network. Okay. Now, for the mobile station of mobile devices, which is general devices until you plug in the SIM card. So the SIM cards identify the users, okay, which for the general equipment of mobile devices. That mobile device again have a transceiver, which can transmit and receive signal. Now those mobile devices will connect to base station. Okay. Now the base station has a base station or base station subsystem contains a base station controller plus the base station transceiver station, or what we call generally a base station. Now each of those base station or base station transceiver is defined as single cell, okay, which including radio antenna, transceiver station, and a link to a base station controller. Now the base station controller is the functions to reserve a radio frequency for each of those base stations, manage the hangoff between one cell to another cell for the mobile devices, and control paging. Okay, so the page user will come, he decide where the paging signal should send it to. Now from there on, the base station subsystem, we have what we call the network subsystem. Now the network subsystem provides a link between the cellular network to the public telephone switching network, or PSTN, okay, which control the handoff between the cell that's in a different base station subsystem. Okay. It also authenticates a user validator account, enhance any type of roaming, worldwide roaming, for example. Okay. Now, the central element of the base station subsystem is the mobile switching center, or before we talk about mobile telephone switching network or office, mobile telephone switching office, or MTSO. So that's the central element of that to control everything. Now, besides the mobile switching center on the base station network subsystem, you will have a set of a database. Those databases are keeping track of variety information. For example, on the home register database, stores information about each subscriber. For visitor location, it's the database that maintains information about subscribers' current location. They are moving to specific location, so you can do a paging and how to find those users. Then you have authentication center database, which used to authenticate some authentications, hold encryption key, so on and so forth. Then you have an equipment identify register database, which keep track of different type of equipment that's existing in a mobile station. Okay. All right. So that's entire cover of the GSM architecture. So GSM architecture is very similar to from before to right now. It's a very similar structure. You will have mobile devices connect to a base station. The base station has the base station controller. Controller connect to network subsystems, mobile switching center. Then it has database keeping track all the information regarding the user's location, authentication, so on and so forth. And also provide a service, of course, to allow you to connect to public switching telephone network, or what we call home phone network. Okay. How? Any questions so far? 有没有任何问题？ Okay, again 有问题你可以 just turn on your microphone. Okay. 好 now we also talk about the third generation now comes along with what we call a CDM take advantage of CDMA, which we've been talking about. Now, the advantage of CDMA cellular network is you're able to do a frequency diversity, okay, which frequency is independent to transmission impairment, such as noise, select fading, so on so forth. Also, the advantage on the CDMA has much better multi-path resistance because the chip code using on CDMA across has very low cross correlation and very low autocorrelation. Okay. Now, it also provides CDMA also provide the privacy which inherited in since the person is using in the CDMA. So it is very graceful degradation, means the system only degrade as more user access the system. Okay, so the graceful degradation is very good, means the more user comes along, it just gets slower and slower. Now the user comes in and I totally reject the user to use the system, like first generation or second generation. If my logical channel or physical channel is not available, I simply reject the users to enter the system. So the degradation of the system compared to first and second generation, third generation is much better because the more user I use, the speed just gets slower. You will not reject the users that comes in. You will not likely to reject the users to come in. All right, so the throwback. So you had the advantage of CDMA. Of course, you have a drawback on the CDMA. The first drawback is the self-jamming, which on arrive transmission from the multiple user, if they are not lined up, okay, if they are not synchronized, okay, on the chip boundary, okay, then you have a problem, okay, so you will jam yourself. So that's the problem of self-jamming. The second problem is the near-far problem, which is the signal close to the receiver or close to the base station or that has a less attenuation compared to the signal that's farther away. Okay, so that's a near-far problem. Okay, then you have a soft handoff issue. Okay, the soft handoff issue on CDMA that require mobile devices to inquire new cell before it relink will disconnect the old one. Okay, so that means you need to connect more than one base station at a time when you do the handoff. Okay, so that's what we call a self handoff. You might connect to two base stations at the same time. So this is much more complex compared to the FDMA or TTMA scheme, okay, on CDMA, because now CDMA needs to do all the exchange information, so on and so forth. All right, so one of the design in the CDMA, okay, is for very good design in CDMA is a RIG receiver, okay, because we still have a multiple version of the signal, multi-path, okay, which create a multiple signal that arrive in a specific different time interval. So that RIG receiver try to do is to recover the signal from multi-path and combine them. Okay? So this method achieves much better performance by recovering the dominant signal and treat the remaining signal as a noise. So in this case, they combining all of the copy of the signal into one. Okay? So the RIG signal is trying to do is this. You have generally the data binary comes in, the modulation sends out. Okay, those are the what we have been learned before. The problem is the multipath. The multipath will give you different amount of delay due to the multipath effect, right? Then different multipath has a different attenuation factor. Okay, so different delay, different attenuation factor, they all come in, okay, to the receiving side. At the receiving side, signal will then what? Will try to recover based on the different time, different attenuation factor, and then sum them up together into combining into one single signal, which gives much better of this after combination of the signal. So this is what the RIG receiver is. They will use different delay, okay, and different attenuation factor. And once they calculate it, they sum up together and output that signal. That signal is much better than just treat other signal as a noise. Okay, so that's the good thing about CDMA. You can use in design of the CDMA. You can use the RIG receiver try to do that. Now, so from there on, for first and second generation, third generation, we talk about a little bit on the third generation. Well, not a little bit. We talk about third generation. The view for the general purpose capability of the third generation is the voice quality is is compatible to the public telephone switching network. So the quality of the cellular network is very similar nowadays to the home network, okay, or the landline. Okay, the data rate is now available for people to use 144 kbits per second to 384 kbits per second, depends on the speed of you moving on high mobility or you are just low mobility. It also support 2.2 around 2 megabits per second for office use. It also allows you have a symmetric and asymmetric data transmission. Okay, but the most important on third generation now, they support both packet and circuit switching data services. Now they support packet switching, so we're gonna move on to the data network. Okay, so on third generation, they also have adapted interface to the internet to reflect the common asymmetry between the inbound and outbound, download and upload. You usually download more than upload less. So that's what we call asymmetric traffic. Is you have inbound and outbound. Okay, this is for the characteristic of internet use. You download the email, you're watching the YouTube, you download the data rates much faster compared you upload anything. Okay, now it has more efficient use of available spectrum in general. Okay, which is support wide variety of mobile equipment you can have nowadays. You can have a cell phone, tablet, or mobile laptop that connect to third generation cellular network. Okay, it's a flexibility to introduce some new service and new technology on third generation. On the third generation, move up to what we currently have right now. Okay, well, currently we have almost fourth generation, fifth generation. On the fourth generation, the definition is for cellular is fully cellular communication, which support mobile technology. The most important on the fourth generation now is not partial IP. It's a full IP-based wireless internet now. Okay, so it means everything now runs on IP-based wireless internet. Okay, you will have 100 megabits of speed for indoor cellular network, 100 megabit for outdoor, 1 gigabit for indoor. Okay, you provide end-to-end quality of services. Okay, has a higher security, has any service anytime, anywhere. Okay, which this fourth generation make everyone part of internet. Okay, so the most important on the fourth generation now is a full IP base. Now, again, the fourth generation, of course, compared to third generation, is faster. Okay, it's more reliable. So we see the fourth generation fourth generation cellular network is 1 gigabyte, 100 megabyte for AO2.11g wireless compared to that. It has a much lower cost compared to the previous generation. Okay, it's a multiple standard on the wireless system. You can have Bluetooth, wireless. They are able to somehow allow you to connect to fourth generation AP. Also, it has on fourth generation using IPv6 instead of IPv4 in terms of third generation because of IP addresses are running out. So fourth generation adapt the IPv6 technology. Now, also the fourth generation use orthogonal frequency division instead of code division multiple access. Now they break down the frequency now. Now it's AO2.11 followed by AO2.11 standard. Okay, AO2.11 AC is fifth generation Wi-Fi. Okay. All right, so that's a so that's a quick review on last week's lecture. 有没有任何问题 ？Any questions? 你可以问一些问题，我可以喘口气，喝个水。Okay. 好，如果是，请问。
在第22页。
OK。
就是什么是 end-to-end QoS？
End-to-end QoS 就是是蛮像是，譬如说我今天 以前我们在 provide 3G 以前 provide 的 service 是 what we call the best effort QoS， 那 best effort QoS 就是说我不 guarantee 你，我只能在背上现在的 network 状况，我给你最好的 condition，那在 fourth generation 呢，虽然它还是 best effort， 但是它 provide what we call end to end is， 假设我今天用的是 IP phone， 我用 IP phone 的时候，我一定要使用者 A 跟使用者 B， 假设在通电话的话，我要 guarantee 他们两个都可以听得非常清楚。这个 QoS 表示他们的 quality 这两个 connection 要是非常好的，足够可以通电话或者是视讯。所以在 fourth generation 他讲的这个 end-to-end QoS 的意思是说，假设我今天要用 FaceTime 跟你聊天的话，当我在 making 这个 connection 的时候 ，establish 这个 connection 的时候，我就要有这个 network service provider guarantee 我这个 connection 会 guarantee 会 last， 还有我一定要 certain minimum delay，certain bandwidth， 我必须 reserve 这个 end-to-end 的 connection。对，这就是我们在 fourth generation they provide what we call the end-to-end QoS means。OK。
就是确保两边还是
两边 OK。这个end-to-end QoS 你把它想象成就是我今天有两个 有一个 connection 嘛，这个 connection 你还是一样嘛，对不对？我有使用者 A 是 mobile devices connect to base station，base station connect to MTSO connect to internet connect to not the base station connect to mobile device， 对不对？这会经过非常多层的 connection， 但是以前他可能只 guarantee 说，譬如说我只 guarantee 我从base station 你到 base station， 或 base station 到 MTSO 就这样子而已。我也不 guarantee 中间的网路层，譬如说我 go through internet， 我也不 guarantee 这个东西。但是现在在 fourth generation， 他会做的就是从 end to end， 我有一个 guarantee of a requirement。minimum requirement on quality of service， 所以一定会有一定的 bandwidth， 一定的 delay。OK， 这是 end-to-end service requirement means。
好的。
OK， 好。OK， 好，还有没有任何问题？好，如果没有问题的话 ，we move now to a little bit more detail on the fourth generation of mobile devices. Okay. Now, so far we have been say from first generation to second generation, fourth generation, right? So the first generation we have already talked is analog. Okay, the second generation now is digital. Okay, use CDMA plus CDMA. Now fourth generation use pure CDMA with IP phone, right? And a part of IP. The fourth generation now is OFDMA, orthogonal, with full IP. Okay, so that's from first to fourth generation. So the first to fourth generation also compared by multiple access technique is frequency division multiple access, time division multiple access to code division multiple access. Now to fourth generation is orthogonal frequency division multiple access. Now, so therefore, fourth generation cell network is operate purely on or based on internet technology, okay, which combine with different applications such as Wi-Fi. Okay, so they combine fourth generation cell network with Wi-Fi, then they seamlessly connect it into as a one single network connection. Okay, so to your device, you do not know when do you switch from cell network to Wi-Fi network. Okay, so to basic users, you do not know. You just look at it as I connect to the internet for somehow. Okay, so it combines different technology. Okay, it runs a speed range from 100 megabits per second in the cellular network to 1 gigabyte to a local Wi-Fi anywhere network. Okay, so it is again, it's a full IP-based wireless internet on fourth generation devices. So the objective on the fourth generation is you need to be efficient, high network capacity. Okay, so the normal data rate is between 100 megabits to 1 gigabyte. Okay, it has a very smooth hangout across heterogeneous network. Like I say, cellular network to Wi-Fi network. Okay, it's a seamless connection. Means you connect it to internet all the time with regarding of what type of connection. It also have a global roaming that across multiple network. Okay, means now I can connect to for example my home network to when I go outside to cellular network, go to school, can reconnect back to Wi-Fi network that's at home. Okay, so the global roaming across multiple networks available on fourth generation cellular devices. It has a much high quality of services QoS for multimedia support. Means now you can stream in audio, videos, HD, so on and so forth. It's interoperable with existing wireless standard. You can still operable with 3G, you can still operable with Wi-Fi, so on. Again, OIP system, packet switching network on the fourth generation. So the access scheme on the fourth generation is has an advantage for scalability, such as OFDMA. Okay, now it also provided with a single FDMA and CDMA. Okay, as a part of the generation of the network. Okay, it has a multiple antenna. Okay, so the fourth generation devices now we have multiple antenna, which you have a MIMO, which is multiple input, multiple output, and multiplexing on the multiple direction antenna. It used to send the data to different route across the network in order to increase the data capacity. Means the data can send through different type of route, different type of network, as long as you get that data. It also take advantage of a software-defined network radio, which consists collection of different wireless standard. Okay, which is formed as what we call the open wireless network architecture. Talk about that a little later. Another advantage on the fourth generation is they are now, besides using full IP network, they are using IPv6 data structure, okay, which they remove the need for network address translation. Okay, each number of application with better multicasting and security and route optimization. Support much greater for the wireless enabled devices because now we are using IPv4. Okay, provides more available address space on IPv4, which enable fourth generation encoding scheme. Okay. All right. So the fourth generation cellular network, when at the beginning, you have a two standard they are trying to approach into to win how fundamental structure for fourth generation cellular network will be. First was the WiMAX, which is standardized in IEEE. Okay, it's for wireless mobile wireless broadband access. Okay, which you have a downloading and uploading speed of 128 or 56 megabits per second. But then later on, we come at a similar time. Actually, not later. At a similar time, you have what we call LTE, the long-term evolution advanced. Okay, standard which by 3GPP. Okay, which provides orthogonal frequency division. Okay, for packet access. Downloading speed and upload speed is 100 megabits per second and 50 megabits per second. Eventually, LTE won because LTE structure is favorable for cellular network company. So now, most dominating the technology is LTE for fourth generation, fifth generation. Now the LTE is it's a long-term evolution advance. Okay. Or LTE events, okay, that make most spectrum reuse by deploying a pair of spectrum allocation. Okay, this you just kind of understand. You don't have to memorize it. Just know, okay, fourth generation is based on LTE. Okay, now what is LTE? Then that's it. You don't need to know too much about it. Okay. Well, you don't need to go into detail unless you are doing research in this area. Okay, LTE deliver the packets at a data rate up to 173 megabits per second on fourth generation. Okay, which reduce the latency to 10 milliseconds only. Okay, which level the old flat full IP network because they are using IPv6 structure. Okay, We also take advantage of a multiple input, multiple output antenna, which using 4x4 multiple input, multiple output, 4 input, 4 output antenna. And the downloading rate, and you can jump up to 326 megabits per second. You can think about now I have a multiple antenna that uploading, multiple antenna downloading. Okay. Now, again, at LTE, you have a much sophisticated multiple access technique using orthogonal frequency division. Okay. And on a single, for download, using orthogonal frequency. For upload, using frequency division multiple access. For upload and downloading, they are using different type of multiple access technique. For modulation, okay, for LTE, they're using QPM, okay, 16 QAM or 64 QAM, okay, for modulation encoding. So we learn about QPSK, QAM, right? So those we have been learned. They are using this modulation technique for LTE. They're also using adaptive multiple input, multiple output antenna for upload and download. You can using 2 or 4, okay, on each upload or download, okay. Also, they are able provide the availability of Wi-Fi offloading. So using 4th generation, 5th generation, they are also using Wi-Fi offload, which means they have approximately 30 to 40% of LTE usage will be home or office. So that mobile device can support transparent offload to the Wi-Fi, okay, or the Wi-Fi to a neighbor site. Later on, we'll talk about a femtocell, okay. So because they are able to using Wi-Fi offload, so they also have reduced the cellular size or cellular base station size to femtocell. So LTE provide a femtocell node, which is much smaller. Okay, it can handles up to 100 megabits per second. Okay, at the low location. Low power location determination of around 0.5 meter of accuracy, so they can determine location of the devices because the coverage of the femtocell is very small. Let me see. So therefore, it also provide what we call the mobile load balancing on the femtocell. Okay, so the femtocells is this. Okay, this I take in the slide from my another class called advanced computer networks. Okay. The femtocells are this. Okay? The femtocell, what it needs, what it can provide is high data rate and seamless coverage. Okay, in a different area. The signal strength is much weaker. Okay, in a building. So inside the building, they put the femtocell as what we talked about before. Okay, and because they are more than 50% of a voice device and 50% of a voice call and more than 70% of the 4th generation are data cell, right, starting from an indoor environment. So therefore, deploy a base station in a building is a need, it's a requirement. However, you cannot deploy a very big base station in a building, for example, Taipei 101, right? So therefore, a very easy solution to shrunk the cell to kind of like a Wi-Fi station, okay, Wi-Fi AP, okay, so you can deploy those inside the building, which you cover the connection in the building. Now, the femtocell is a very efficient way to recover or to cover the coverage hole. Okay, this is concept of femtocell, or this is okay, or quick concept of a femtocell. 有问题吗？来，请说。
老师，就是 WiFi offload 是什么意思
？WiFi offload 其实非常简单。WiFi offload 就是像是假设我今天在用你的 devices 打电话 ，OK， 或是你的 device 在上网，所以如果你在外面的话，你一定是用 4G 的网络，对不对？
嗯
，OK。但是你一回到家，或是你一到有 WiFi connection 的地方 ，OK。Most of 4G 的 devices will switch you to Wi-Fi connection。这个就叫做 Wi-Fi offload。它把原本你的 traffic load 从 4th generation cellular network switch 到 Wi-Fi connection。OK， 这就是 Wi-Fi offload 的意思。OK， 好 ，All right。 So back to the femtocell. So if you can take a look on this figure, right? Before we will have mobile devices, mobile station that connect to a base station, right? The base station will go through base station controller to MTSO to the telephone core network, right? Okay. Now, or you can go to best internet. Now, for the femtocells, the femtocell, okay. Now you are allowed your femtocells to directly connect to the internet, okay. So it means your device, if connect to the femtocell base station, the femtocell will directly connect to the internet. Then the internet, if you want to go to the telephone network, you will go to what? Femtocell gateway. Go to the femtocell gateway. Then the femtocell gateway will direct your call to the telephone core network. Okay, that's what femtocell is. But the femtocell, the good thing is, instead bypass all the core network, those stuff of the base station, the femtocell allow you to go to the internet directly. Okay, has an internet interface. Okay, so it has a wireless interface for the fourth generation. Then connect you to with the internet interface. Okay, so that's a full femtocell is. Okay, so that's a quick overview. So the femtocell, if you compare that, the femtocell cost per year, they are all telecommunication standard. Okay, so the interface are all telephone communication standard. The backhaul on the different one between a femtocell and microcell is the backhaul, okay, of the femtocell is the broadband internet. Okay, however, in the traditional cellular network, the backbone is still telephone network. Okay, so the cost to run a femtocell usually are $200 per year, compared to the femtocells roughly $60,000 per year instead of $200 per year. Okay, they are all US dollar. Okay, now another thing, a good thing about the femtocell is the power consumption on the mobile devices are very low compared to the microcell. Okay, the range between the femtocell, the radio range is 10 to 50 meters compared to the microcell, so 300 to 2,000 meters. So therefore, the benefit of the femtocell network is much better coverage. Okay, enhance the capability. Okay, lower the transmission power, especially for devices. Prolong the standard battery life because they lower device power. Okay, higher signal to noise ratio, but you still have a little problem on the handoff because now you do a much faster handoff. You have a synchronization, self-configuration, and the location tracking because now the connection range is 10 to 15 meters. You can much easier to track location. And also the security issue, okay, that you can provide it into the femtocell, can address in the femtocell. Okay.
确认一下，右边的不是 the stuff on the right side is not benefits, right?
The standard on the right side, it's an issue, not necessarily the benefit, because now you need to do the hangoff consideration. You need to do a synchronization. Okay, those considerations is a little different compared to a cellular network. Okay, so they are not necessarily a disadvantage, but they are more complicated.
It's cheaper, but does it service more people when it adds up?
It will serve more people in terms of journal, because now you have, for example, on this one, in one single base station, one single area you cover, you will deploy many femtocell, right?
Yeah.
So say if each femtocell can able to support 50 people, but the area is smaller, I can repeatedly serve 50 people. Remember, we do the calculation if we reduce the cell size. So that's the same thing if we reduce the cell size.
Yeah, okay.
So if you can take a look at this one, if this base station is microcell, then I can support 50 people on this big area.
Mm-hmm.
But if this is the femtocell, I use the same frequency division, right? Then I can support 50 people here, 50 people here, 50 people here, because my coverage are less.
More condensed.
So it means that overall the system, the network capacity is much better, or network utilization are much better compared to the one single big cell.
Oh.
Okay, so that's the issue on if you talk about the capacity. Okay.
Okay.
Okay. All right. So therefore, so on the femto cell for LTE, the common feature for whether it's WiMAX or LTE is they are LTE using what we call a orthogonal frequency division multiple access with multiple input, multiple antenna. Okay. Now the users can allocate a slice of time and frequency. Okay, to do allocation. Okay, it's very flexible. It's very dynamic for each user's allocation. It's a base station. The base station scheduler for uplink and downloading are different. So the resource allocation on converged frame by frame basis, not connection by connection basis. Okay. Now, also it supports time division and frequency division at the same time, along with orthogonal frequency division. Okay. All right, so that's the fourth generation. Okay, the fourth generation is one we've been using for years now. Okay, so we're gonna move on to the next generation, or we are already on in the process to moving on to the fifth generation. Yes.
老师就是
是
femto cell 跟 macro cell 也是不会重叠的，对不对？
femto cell 跟 micro cell 可能会重叠啊，
哦，可能会重叠。
因为 femto micro cell 它有时候，譬如说假设我们放在台北的某一区，对不对？
嗯，
但是台北的某一区可能，譬如说你在台北101，它是没有办法 connect 的。譬如说像师大资工系里面，其实它没有办法 connect to some cellular services， 那你就可以放一个 femto cell 到里面去，它是会重叠的。
嗯
OK，
嗯，
所以未来它会变成一些服务乡村、一些服务市那个 femto 服务市区，然后 macro 服务那个乡村地区这样子吗？
一定会是这样。对，就是因为你可以想想看啊，如果在远的地方，它没有办法去cover 这么密集的时候，应该是说它也并不需要。比如说我们今天在我现在在新竹好了，新竹地区它可能就并不需要像台北101或信义计划区这么多的这个 cell， 因为我没有这么多人在这附近同时间使用 internet， 那可能 micro cell 就够了。OK， 但是
在一台车上，例如公车或是高铁这样子。
公车或高铁怎样子？什么意思？
就是公车或高铁都会提供 WiFi 的样子。
它提供的 WiFi 是 WiFi，然后再降到它的这个 Wireless AP 上面去。
Wireless AP， 所以它跟那个电信的不一样，这样子。
它可能是再用另外一个，应该是说它有点就是 provide 一个 hotspot 的概念。hotspot 就是比如说你的手机开了 hotspot 给别的东西，比如说你的笔电去连接是一样的概念。OK， 是在这种高铁上面
一个 relay 这样。
对。
那就是不同等级的 cell 可以重叠，然后同等级的不可以吗？
同等级的 cell 尽量不会重叠。OK， 对，因为重叠没有太大的意义啊。因为重叠它会有 interference， 有着很多很多的问题。
好的
，OK，
好，
所以就是最基本的就是它只要重叠，我只要让它讯号频段不一样，就它要怎么重叠就它爱怎么重叠就怎么重叠。
但是不 efficient 嘛，对不对？所以因为这些东西还是要 cost 的嘛，对不对？所以假设我今天是一个电信公司啊，我不会放这么多重叠的东西在一起，因为我放重叠的东西在一起，第一，我的 channel 不可以我 interfere， 所以我一定要就 channel 的 separation， 对不对？第二，我 support 的 user 一定会 connect one of those two， 但是如果我重叠的话，我两个都会 cover 同一个 area， 我并不需要这样做啊。OK， 所以对于电信公司来讲，当我在部件的时候，我尽量不会让它重叠到。
然后 femto 比较快，所以两个重叠的时候，手机通常会优先去连 femto cell。
手机会优先连信号强的。
OK，
永远是信号强的。
可是通常大区的，我刚好在那根柱子旁边，它就会信号最强。
它一定会连讯号最强的，对不对？
OK，
对。那 通常你会讯号不强，会连到 femtocell， 主要是这个，所以主要是就是你一定是在 building 的啦，对啊，通常你在 building 讯号通常都是 femtocell 比较强 ，OK。
哦，因为装在里面，而且很小颗这样。
Of course， 对啊，而且它其实装的蛮密的，对啊。
哦，
对啊，你想看50 to 100 meter， 它就装了一个，所以如果你仔细去看，去台北夜莺或新区去，你其实是可以蛮常看到这个 femtocell 在某些地方。你以为它是 wireless AP， 它其实是一个 femtocell。对 ，OK。
老师，我想问一下 femtocell 跟 wireless AP 它是差别在哪里
？OK， 没问题。femtocell 它的 connection 是一种 fourth generation cellular network 的 connection。OK， 但是 WiFi 是走 pure AO2.11 的 connection。OK， 好 ，What's that saying？ 为什么他要做 femtocell？ 为什么他不就台北夜莺不就放一大堆 AP 呢？哎，主要的原因是电信公司想要算要 charge 你钱啊，因为 femtocell based on 的是电信公司嘛，对不对？所以 if you use their cellular network， 你就要付费嘛。当然，如果你是吃到饱的，那没话说。但是如果你比如说一天一个月是20 G 的话，或者说是几十 G 的话，那就会开始 deduct off your usage 嘛。所以你的 device 你的 device 通常会 connect 到 wireless AP first， 就是Wi-Fi AP first。OK， 所以你的 device priority always 先 connect 到 Wi-Fi， 因为电信公司虽然想要 charge 你钱，但是他也不想要你一直去占着他的这个频宽，所以你的 device 要是可以 access 到 Wi-Fi 的话，通常的 device first choice always Wi-Fi。OK， 所以再回答你两个不同的地方，其实他们非常相似，因为他们都会 directly connect 到 Internet。OK， 只不过你的 access， 譬如说像在这张图上面，这个 mobile devices access 到 femtocell base station， 它走的 connection 是4G，OK， fourth generation。OK， 但是如果今天这个东西是 wireless AP 的话，那你的走的 connection 的 protocol 协定就是 AO2.11 的 protocol。
所以 WiFi AP 的 backhaul 也是 broadband 吗？
那不是 WiFi AP 的backhaul 是 Internet。OK，
是 Internet。
对。
啊 ，broadband 跟 internet 的差别是
broadband internet。OK， 这个是 broadband internet 哦，这还是 broadband 哦。OK， 如果你有 WiFi 的话，它是 pure 就是 internet。
所以 broadband internet 不是 internet，
它是 internet 的一种，但是它是好，你可以把它想象成是同样的东西，但是它实际上是有一点点不太相同了。你可以都把它想象成是 broadband internet， 你可以或者把它想象都是 internet 是 OK 的。OK。
然后前面那个可以想象成就是那个电信虽然打电话也是走 IP， 但是每一家电信会希望把它的频宽留给打电话的人这样子，
或者是没有 WiFi connection 的人，
没有 WiFi。OK，
对，譬如说我今天是在师大，对不对？你师大就有 WiFi 嘛，对不对？但是因为你是师大的学生，你的 device 就会 automatically switch 到师大的 WiFi。但是如果你不是师大的学生的话，你就算有 WiFi 的 AP 在那边，你也没办法 access 到 WiFi 的这个 network， 它就会还是让你走 cellular network structure， 主要是这样。OK。
想问一下那个 UE power consumption 的 UE 是什么意思
？UE 就是 users equipment， 就是你的手机。
了解。那个 femtocell 本身它的 power consumption 也是比较低的吗？
一定都会比较低，因为它只需要 cover 非常小的 area 嘛，对不对？你看它的 radio cover range， 无论是收或发都是，假设我发这个讯号出去大概是50 meter 嘛，对 ，compare to 我的 microcell， 我发的这个信号，我讯号要打出去是300 to 2000 meter， 所以讯号打出去一定要比较强一点点。对 ，compare to 这个one， 那无论是users equipment， 或者是你的 mobile phone， 或者是你的 AP。femtocell 它的使用的 power 都会比较低一点 ，compared to microcell， 因为你无论是讯号要接到 microcell 和讯号打到 mobile device， 它都是比较长的距离，比较长的距离就需要比较大的 power。
像是手机就接收端也会知道差别嘛，就是他知道说他连到 femtocell 或是 microcell。
手机一定知道，手机因为它一定要知道它，所以它一定要讯号打出去的那个 power 要不一样。
OK，
应该是说，手机无论是 connect 到 femtocell 或 microcell，it doesn't matter。你还记得我们做这个 power consumption 的这个 power control 的这个东西吗？这个 open loop 跟 closed loop，他会看这个我进这个讯号发射进来，我同样要打回去多少？我 by listening 那个 pilot 的 signal。
所以是一样的
connection， 就是 fourth generation， 你的 connection 都是4G connection， 无论你是 connect 到 femtocell 或是 microcell， 只不过你要怎么用它的这个 frequency 啊这些东西，你都是要看这个 handshake 的协定上面做。OK， 所以你看。最一开始 air interface 就是手机对于device cell 的一个connection，air connection 都是 telephone telecommunication standard， 这两个是一样的。femtocell 跟 microcell 都是一样的，所以你的手机 connect 到 femtocell 或者是 microcell， 和 femtocell 跟 microcell connect 到你的手机都是 telephone communication standard，OK， 只不过它的 femtocell 的 backhaul 是 broadband internet， 然后 microcell 的 backbone 是 telephone communication network，OK， 好，还有没有问题？好，没有问题。We move to fifth generation of cellular network. Okay, now the fifth generation cellular network, of course, okay, we always says 4G is not fast enough. Okay, because they do not support bursts of data traffic. Now, if you take network communication, you should know this is data communication. We talk about most internet traffic are what we call the burst traffic. Means I suddenly download something, then I did not. Okay, I suddenly open up the web page, then that traffic gets burst. Or I suddenly download a bunch of my email. That's a burst traffic data type. Okay, so the fourth generation does not support the burst of data traffic. Okay, it also inefficient of utilizing the processing capability of the base station. The base station can be processing a bunch of stuff. Okay, it also has a congenital interference in fourth generation and does not support heterogeneous wireless network. Okay, and there's no separation between indoor and outdoor users on fourth generation. So, and in addition, 来，请说。
就是那个 no support for heterogeneous wireless networks 的那个 wireless networks 指的是哪些呢？
它指的是比较像是不同的 application， 譬如说像是vehicle network，OK， 像是IoT devices，OK， 这是4G 不 support 的 ，OK， 或者是machine to machine communication。Okay, vehicle to vehicle communication， 这些东西 fourth generation does not support， 因为 later on 我们要 move on to from anyone to connect to anything connect。OK， 所以比较像是这样子。OK， 好。OK， so fourth generation moving from fourth generation to fifth generation is roughly breakdown between 其实是2019年 ，OK， that we start moving toward from fourth generation to market to fifth generation. Now from now on, a lot of people are using fifth generation. Now, so therefore, if by looking on the mobile traffic growth, okay, you will see, okay, from 2005 to 2015, the growths are really huge. Now, grow in the data centric of a business, they are jumping from 2013 to 2019, probably 10 times more of the data traffic. Now, traffic per user from 2019 per user in average per month is 2.2 gigabytes or more. Okay, last time I checked my son's, the last month's mobile usage is 20 gigabytes. Okay, so you can see the mobile traffic gets a lot already in terms of traffic nowadays. Okay, so therefore the fourth generation is not enough anymore. Okay, so therefore, which brings us to fifth generation of cellular network. Now the fifth generation cellular network is 10 times more capacity compared to the fourth generation. Now the speed is now expect to up to 1 gigabyte per second. That's 1 gigabyte per second. It's much faster and much reliable compared to fourth generation, and the costs actually are lower than the previous generation. Okay, so you can see the fifth generation, the mobile data is 10,000 times more. The connected devices nowadays is roughly about 100 times more compared to the fourth generation. The latency is 5 times more. The user's data rate and those battery life are 10 times less, right? So you can see the fifth generation are the future that we need to connect everything, okay? So we compare the first to fifth generation. 是
老师，那为什么5G 比较便宜？
5G 比较便宜，是因为你更多人使用，然后很多 device 同时间要用。那主要的原因是5G 它会把它放得更，有点像是把它放成 femtocell 的这种 size，OK， 表示我可以 support 更多使用者同时上线。你越多使用者在用这个 network 的时候，你 cost per byte 就会降低。对，譬如说我今天只有10个使用者使用这个 cellular network， 和我是有1万个使用者使用这个 cellular network， 我的这个 cost 一定会被分。从10个使用者被分到1万个使用者的身上，所以相对的 cost 就会低了。
好的，好的。
OK， 好的 ，OK， 好，来，那 so we compare first to fifth generation. The first to fourth generation 我们已经 compare 了嘛 ，of course， 速度一定会不一样嘛，对不对 ？So to the fifth generation, the most important is the speed. OK。Is gonna be faster than 1 gigabytes per second on fifth generation. OK， 那其他的都差不多，同样是用 CDMA， 同样都是 packet base， 同样是大部分的 core network， 从 public telephone switch network, packet network. Now fourth and fifth generation they are all set internet now. OK, so the fourth generation, fifth generation, the main difference is the speed, and with the speed comes along with you allow more people to connect. Now, another little different on the fifth generation network is the fifth generation mobile network layer. 现在 they design more closely to the internet or computer OSI layer type of device, because we are using most of the fifth generation devices are followed by some computer protocol. Okay. They are not only using for making a phone call anymore. Most of the device, for example, your mobile phone or your iPad, or even the car that connects to internet, they all follow by some type of a computer architecture, which that architecture follows for the networking layer are followed by the OSI layer. Okay, so if you put side by side of the OSI layer and fifth generation cellular network layer, they look quite similar. Well, they are break down to layer very clearly. So we start off with from the bottom. The bottom is open wireless network architecture. Okay, that's 对应 now or to the OSI layer 1 and layer 2, which divide the wireless technology. Okay, this two layer, there's two for those two layer, the mobile devices, fifth generation mobile devices are based on the open wireless network architecture, which that including physical layer plus data link layer. Okay. Now, if we move from the physical and data link layer up to the network layer they break down to upper level and lower level layer. Okay. Now, for fifth generation, all mobile device will be using mobile IP. Okay, I will explain the mobile IP in the next section of the class. So if you have a question, hold it a little bit. Okay, so all the 5th generation mobile device using mobile IP. Okay, each mobile terminal can be a foreign agent. I'm going to explain the foreign agent a little bit later when we talk about mobile IP. Just remember that each mobile device can become a foreign agent. A mobile device now can connect to several mobile or wireless networks at the same time on the 5th generation. Means at the same time you connect to 5th generation cell network also connecting at the same time of the Wi-Fi connection. So they connecting everything at a similar time. Okay. They also using IPv6. Okay, which was the fixed IPv6 implement in the mobile phone, which from 4th generation we are using IPv6 to 5th generation still using IPv6. The separation of the networking into upper layer and the lower layer. Okay, for lower layer is for the interface, upper layer for the mobile terminal. For different mobile terminal, you can have a different upper layer of network structure. So to your knowledge, just think about that as networking layer. Okay, so we're going to talk about mobile IP in later of this course. Now, from the networking layer, we'll move up a little bit, called Open Transportation Protocol. Now, the Open Transportation Protocol that different from the wire regarding of different type of wireless technology. Okay, so in this Open Transportation Protocol, all the TCP IP, so the bottom networking layer is IP, mobile IP. The upper layer is TCP, okay, which assume that's a lost segment due to the TCP will have to covering network congestion, network connection, so on and so forth. Okay, so if you've taken the networking classes, you should know TCP IP layer. I'm gonna recap a little bit if you do not know. I also talk about that a little bit later in the course. Okay. For the wireless, the loss might due to the high bit error in the radio interference. Okay, so therefore, in the 5th generation, the transportation layer is possible to do downloading and install any type of open transportation protocol in this layer. Okay, so the open transportation layer is transportation layer plus section layer. The section layer has to do with the bit error rate, network congestion, so on and so forth. Okay. From there on, we have on the very top layer is application layer. Okay, the application layer is the one where you provide the quality of a service management over different type of network, because it's very hard to provide a quality of service if you connect to internet, you connect to cell phone, broadband, or telephone backhaul. So therefore, you have to somehow adaptably to manage the QoS. Right? It also provides the service quality testing, okay, and the storage to measure information on those different type of network connection. Okay, then from there on, you will select the best wireless connection for a given services. For example, if you're using downloading audio and video, okay, you might using Wi-Fi connection. But if you are using making a phone call from one cell phone device to another cell phone device, maybe telephone network might be a better connection. So they may select different types of wireless connection for different services. Now, the QoS parameters such as delay, loss, bandwidth, reliability will all store in some database in the 5th generation mobile devices. So if your devices provide the 5th generation connection, 5th generation of 5G connection, then you will have those information stored in your mobile devices. Okay, the application layer, including presentation layer plus the application layer, they are all called application layer in the 5th generation structure. Okay, now the advantage of the 5th generation is the bandwidth now is up to 1 gigabyte or higher. Okay, it has a dynamic information access. It has available with a low cost. Okay, it has a much better quality of service. Okay, paging will be upload instantaneously. Means you open the web page, the device will select the best connection and bring up the page for you. Okay, it supports interactive multimedia, video streaming, audio streaming, so on and so forth. Any type of broadband service nowadays for the 5th generation. Okay. However, there still is some disadvantage on the 5th generation services. Okay, such as because we are using ultra high spectrum band. Okay. Therefore, because that ultra high spectrum, okay, the shorter distance, the travel distance is shorter compared to the low band. Okay. So therefore, it's more suitable. 5th generation connection is much suitable for indoor coverage, not for outdoor. Okay, not for long distance, not for when you are traveling on highway. It has a high frequency, could be blocked. Sorry, on the 5th generation, because it is using such a high frequency, it could be blocked by the building, which they can right away lost the connection or lost the intensity over long distance. So means if you want to offer the wire coverage, this can be a challenge on 5th generation. So therefore, we still did not see a full 5th generation coverage in most of the area, because you need to deploy a lot of femtocell-like base station for 5th generation cellular network. Once you have those femtocell very densely deployed, then 5th generation cellular network can be much more popular compared to nowadays. All right. So the exact application for 5th generation, like I said, mostly everything connected, everything that will be connected: house, building, city, vehicle, sensor. Okay? There are different ways interaction. Okay? And could be health services, could be infrastructure services, infrastructure control, so on and so forth. Okay? It also has a remote control, okay, to control unmanned vehicle or drone. But then those type of connection are a failure is not option. Okay, so the application for 5th generation are endless. Everything you can think of in the future should be connected to a 5th generation cellular network. Okay.
Is there anything stopping? Is there anything stopping from installing 4G on cars and refrigerators?
Anything stopping? What do you mean by that?
就是有什么原因会让4G 不能装吗？还是4G 其实也可以，但是因为某些因素而不这样做
？4G 可以装，但是没有那么好的 advantage。原因是如果你要用一个4G 的话，第一像譬如说冰箱好，它并不需要打那么远，对不对？所以它不需要打那么远的时候，你为什么要装4G？ OK， 你可以直接用 WiFi 嘛，对不对？那 for vehicle 你当然可以用4G。WiFi
也是很短的一种传输距离的东西吗？
WiFi 就是你家里面的 wireless AP 嘛。那传输距离就是普通的嘛，就是大概50到100个 meter， 就是 cover 你家里就够了的这个 range 嘛，对。那你说 vehicle network 为什么不用 4th generation？ vehicle 其实现在很多 vehicle 都是用4th generation， 甚至是 3rd generation actually。Okay，the reason is this: vehicle 一开始至少在现在来讲，它并不需要这么 fast 的 connection。OK， 所以很多 devices 它其实是反而倒回去用3G。OK， 因为3G cover 的距离非常远。compared to 4th generation。OK， 所以它会用3G， 因为它并不需要这么快的速度。OK， 所以它有的时候根本并不需要用到 5th generation。OK，unless 你这个 connection 是 share， 譬如说，我们讨论到 in the future， 像我们刚刚现在等一下要讲的，就是 in the future 这个 entire highway 或者 entire 这个 transportation infrastructure are connected to internet， 这个时候你就会需要大量的 connection。
那刚才说 share 是两台互相要沟通，
没有，share 是说 N 台要直接 connect 到 central control station。
就整
对那这个时候
整条路上都是 connect to internet， 但是不是说两台这样子。
不是说两台。
OK，
两台的 connection 通常都是用Air Hub type connection。
Air Hub
Air Hub 就是 mobile Air Hub network， 或者是 vehicle to vehicle communication。车跟车之间的通讯叫做 vehicle to vehicle， 车跟 infrastructure 叫做 vehicle to infrastructure V2I。 OK， 好 ，OK， 所以除非你是所以 depends on what you talking about， 像是 if you talk about vehicle to vehicle， 那你甚至并不需要用cellular network， 像 vehicle to vehicle， 我们通常的 standard 是 AO2.11， 我记得是A。它是based on AO2.11a 的这个
它也是 WiFi 的一种，
它是用 WiFi 的 connection 去 connect vehicle to vehicle， 但是 vehicle to infrastructure 现在有用4G， 现在有用3G，
距离需要比较远的就会用3G。
没错。然后速度资料传送量不需要那么大的，但是在未来资料传送量一定会变得非常大，那它就要 switch to fifth generation， 而且 fifth generation 的 coverage 是非常小的 cell 嘛。你就会在整个 highway 上 deploy 一大堆 AP， 主要是这样 in the future。OK，
就是它刚好可以 cover 到路的宽度就足够了，
然后大概一段距离你就放另外一个 AP。OK， 好 ，so bring back，so top usage on the fifth generation，right？ We think in the future is the interaction between human or IoT。Okay，so the IoT will be one use of fifth generation。Okay, you want everything connect to internet. Okay, and you have a broadband experience everywhere and anywhere, anytime. Okay, 所以这也会是 fifth generation usage. Smart vehicle, smart transportation infrastructure will be another one. Okay, critical control or remote control devices， 像是 drone 啊，或者是国外现在正在 push 的就是那个using drone to farm 无人农场 okay so it means everything is robotic control okay now till the future media everywhere you go anywhere you go is video streaming anywhere okay so that's we think the top usage on the fifth generation of cellular network okay on top of that I think the most valuable future is first thing is of course the IoT, that everything connected, with fridge connected, vehicle connected, your shoes connected, your watch is connected, right? Chill. Another good area is a massive machine to machine communication, vehicle to vehicle, vehicle to infrastructure, vehicle to anything, right? Then the next one, I think we think will be is a critical control in the remote devices. Okay, control unmanned vehicle, control unmanned machine. Okay, those are I think the top usage for fifth generation of cellular network. Okay, so what's that saying? Okay, if we compare third, fourth, and fifth generation, you will see the difference. The third generation is operator centric. Okay, means they are mostly central designed by four the operator. Okay, like 中华电信、台湾大哥大. The fourth generation, the design are mostly service centric. They are provide service anywhere. Okay, the fifth generation are what we call a user centric. They are now focused on users cases. Okay, for fifth generation.
Service doesn't mean ISP, right?
No, service means service some application, video streaming, YouTube, Spotify, that kind, Netflix.
Okay.
Those are what we call the services.
And is operator ISP?
Operator is ISP. That's right. So
okay.
the third generation design still focus on operating 像是中华电信，中华电信它的你看3G 的 design，they are based on cell tower，based on how much I can charge you, so those stuff, those are what we call operator centric。因为they move from cellular network to they move from the telephone network to
他们去租场地来摆这些设备的吗？
再讲一次。
那个现在不是也还是 operator 去租场地，例如3G、5G 都是他们中华电信去租tower 来摆这些设备。
但是they are focused more of provider services now。这个 services 是 any services。Any services。Internet services 啊 ，telephone services 啊，等等这些东西。
哦，so operator centric means 原本就是只有 telephone centric。
没错。
OK。
好。So the 5th generation is user-centric. Okay, means now we focus more on users, what the users need now. Okay, so that's the 5th generation. Okay, so the 5th gen wireless structure, we call it open platform at different layer. Okay, it will has a new coming of a 5th generation technology be available for the market with much affordable rate. Okay, means you can now allow your anything that connect to internet, your vehicle to connect to internet, your car connect to internet, not car, your shoes connect to internet. So, but those are much affordable rate, okay, and with much more reliability compared to previous technology. So means they are always connected, okay. All right. So that's the 5th generation. The next one we're going to move on to is mobile IP. But before we move on, let's take a little break. Okay. 现在是3:40 OK 3:40 we start at 4点好了，我们 take a 20-minute break。 OK， 中间你要是有任何问题你可以 ask me OK 好不好？ All right, so let me stop the break time. First thing is you can sign off at the break, come back and sign off and take a break and come back at 4点好了 we come back 4 o'clock. Okay, so you can sign off. Okay. 好，如果中间你有任何问题，你可以问我。OK。
老师，
是，
我想问，就是那个4G 就使用 IPv6，然后说可以 enable 4G coding schemes innovation。4G 的 coding schemes 在这里是指什么啊？
你在哪一页？不好意思
，30页。
30页。你可以把它想象成，其实它的4G 的 encoding scheme 就是比较像是，譬如说我可以 mix and match 不同的就是connection， 譬如说4G 我们会用CDMA 再加上Falcon， 或者是你可以把它想象成是 frequency 再加上 time 再加上 code，OK， 表示这个它可以 mix matching，OK， 表示那怎么去 mix match？是我有 based on 我今天这个 application 需要多少的 QoS， 我的 quality service 需要多快，或者是我的 connection 需要多快，然后 based on 我 connect 到这个 这个 base station 这个 base station 跟我讲说，在这个现有的 available 的 connection 里面，我可以怎么样把它的 encoding 去 encode 成你所需要的这个bandwidth requirement 或者是 data rate。对，这是话这一句话谁就是它可以用不同的 encoding scheme 去 adapt 到你的required connection speed。OK， 好，
谢谢。
没问题。